Okay, today I'm going to talk to you about alkali metal reactions. So alkali metals are in group 1 of the periodic table. They are lithium, sodium, potassium, rubidium, cesium and francium. There's a pattern as you go down the table in terms of reactivity. At the very top, so lithium is the least reactive, and the further you go down group 1, the more and more reactive you get until you get to the bottom, where you have francium, which is the most reactive. Now, what we need to know about is how alkali metals react with water. We're going to pay particular attention to these first three: lithium, sodium and potassium. So imagine if I have a tub of water like this. So here is my tub of water. Now, these alkali metals are very reactive metals. They're so reactive that they react with water. So if I had my metal and I put it into the water, I would see a reaction. Now, the reaction is slightly different depending on which alkali metal we have. So first of all of them, so all of these three that we're learning about, would start fizzing and skimming across the surface. I would also see a gas being produced as well, so fizzing and a gas being produced. So for lithium, I would see fizzing and it moving across the surface. Now sodium is more reactive. So it's so reactive that it would, in fact, it would start to melt as it moved around the surface. I might even see a yellow flame. Apologies, you can't see that particularly well, but a yellow flame. Now, potassium is even more reactive. So it has an even more vigorous reaction, even more fizzing. And quite often, we will see a lilac flame. So we can actually see a much more vigorous reaction. Now, the reason why we get a flame is because the gas produced is hydrogen. And hydrogen is a flammable gas. We know that because of the squeaky pop test is the test for hydrogen, because we literally set fire to the hydrogen and it's flammable. So what we need to do now is we need to have a quick look at the equations associated with reacting an alkali metal with water. So I think it's best to look at a particular example. We're going to have a look at lithium, then potassium. So imagine if I add lithium to water, this is how I write that. These have reacted together. Now I always produce two particular products. A hydroxide, in this case lithium hydroxide, and hydrogen gas. Now, these are the two things that I will always produce, a hydroxide and hydrogen. The identity of the hydroxide depends upon the alkali metal that I've used, and we'll see that in a minute. Now, these hydroxides, they are alkaline. And I could test for that, for example, by adding universal indicator to this water once it's reacted, because I should see it turning maybe a bluey purpley colour to indicate that it's now alkaline. So let's have a look at the symbol equation that goes with that. So lithium is just the metal all by itself. Water we should know is H2O. Lithium hydroxide is nice and simple, LiOH. And hydrogen is H2. And to balance it, we just need 2 in front of those ones like that. So what I want to do is I want to compare what this reaction would look like if we were using potassium rather than lithium. So I'm going to write it here. So this time I've got potassium plus water. So this time I still produce a hydroxide, but the name of this hydroxide, instead of being lithium hydroxide, is going to be potassium hydroxide. So again, I'm forming hydroxide, and just like before, I'm still producing hydrogen gas. Now the symbol equation is going to be very similar as well. So I've got K for potassium, water we know is H2O, potassium hydroxide, so it's not going to be LiOH, it's just going to be KOH, and then plus hydrogen, which is H2 again. And the balancing is going to be absolutely identical. So the important thing to remember is the reactivity increases the further you go down the alkali metals, group 1 metals. The gas produces hydrogen, which is flammable, and we also produce a hydroxide. The name of that hydroxide depends upon your reactant, which alkali metal you've used. Thank you.